Hello people, welcome back. The question is from GATE 2014 exam and is for 1 mark. They're saying if host A sends a datagram D to host B, what all fields of IP header may change when B receives this datagram? Okay, now you very well know all the intermediate routers are going to reduce TTL. Okay, so TTL may change. Now if TTL is changed, that means we have modified some field in IP header, then surely header checksum will also change. Okay, so the field called checksum may vary. Also, fragment offset may vary if some intermediate router decides to fragment this packet. See, if datagram D is this, if some router decides to fragment it, that means router decides to create smaller parts of this datagram, then fragment offset will vary. Okay. See, for this fragment, the third one, offset will be this much. Okay. The amount of data contained in these two fragments, except for the header, divided by 8. That will be the fragment offset. We have already seen this multiple times. Okay. So all of these three fields may vary. Answer is 1, 2 and 3. Okay. So the important word in this question is may. They are asking which of these may vary. Okay. That is the reason fragment offset will also be considered. See, fragmentation is not done, then this will not change. But because they are asking may vary, so consider all of them. Okay. Now, in some cases, none of these fields may change. Say A and B are in same network. That means A sends data directly to B without asking help from any of the router. In that case, TTL will also not vary, checksum will also not vary, and fragment offset may also not vary. Okay. So now I'll do one thing. There is a question from GATE 2015 exam. This question is almost similar. Okay. Here we have 3 options. In that question, maybe we have 4 options. Okay. So they're asking a similar thing. That means which all fields may vary in path. So I'll attach this video. You just watch this video. You can understand these things in more detail. Okay. Have a look. They are asking which of the following fields of an IP header is not modified by a typical IP router. Checksum, source address, time to live or length. See, whenever any router receives some incoming IP packet, it will analyze the destination IP address of the packet. Based on its own routing table, it will be decided on which interface this packet has to be forwarded. But just before forwarding that packet, a few changes will be made. Okay. There will be a field called TTL in the header of that IP packet. The value of TTL will be reduced by 1. See, suppose this is the source from where the packet originated. The source will set some value for TTL. Suppose it is set to 7. Source will send the packet to some router. Router will receive packet with TTL 7 and it will reduce it to 6. Okay, so 7 minus 1, 6. Similarly, this router will receive TTL is equal to 6 and it will also decrement it by 1. Hence, the new value will be 5. Now, this router will send the packet to say destination. Destination will not reduce TTL, it will simply accept the packet. Okay. Now, you might think, what is the use of including such a field? It is to avoid infinite loops. Say due to some problem or due to some error in routing table and the routing algorithms, an infinite loop is created here. Okay. This router forwards packets to this one and this one forwards to this one. So packets are using bandwidth and processing power of routers infinitely for creating a useless loop. The solution to this problem is TTL field. See, both of these routers will also decrement the TTL before forwarding. Eventually TTL will become 0. And whenever TTL will be 0, router will discard the packet instead of forwarding. Okay. So that is the reason we include such a field. Now, option C will surely be modified. Okay. If we modify TTL, the checksum will change. Hence, the router will compute new checksum and router will also update the checksum field. Okay. So C and A are going to change. Let's talk about option D. Will length change? See, if I update this field TTL, checksum will change, but it will not have any effect on length. This field is of 8 bits. Whatever is the value stored, it will be in 8 bits only. That means if I change the value of TTL from 7 to 6, the length of this field will be 8 bits only. Okay, even if some router makes that value of TTL equal to 1, still that 1 will be saved in 8 bits. Parallelly, checksum will always occupy 16 bits only. Okay, this checksum is present in the header. Actually, checksum is calculated only for IP header. Okay, the full name of this field is header checksum. They are only saying checksum, but you can easily interpret it as header checksum because the question is about network layer. It is a IP header. Okay. Now have a look. Length may not change if you are updating TTL, but length may change if the router decides to fragment the packet. Okay. So option D also may change sometimes. If this is the packet and router decides to fragment it means create smaller parts from that packet such that they may be transmitted over some network. Okay, so length may also change at times. The only field that will never change is option B, source address. Okay, why would a router modify the source address from where packet originated? We don't find any valid reason for this. Okay, so answer to this question is option B. Now, is there any situation in which router will modify this one? Yeah, there are situations. For example, if you are implementing network address translation, that is NAT. Suppose this is your home network. You have few devices, 2 mobiles, 1 laptop maybe, and a printer. Okay. All of these may use a private IP. In this case, your router is going to modify the source address. Suppose this mobile sends some data packet. It will write its own private IP in source IP. But this router will modify its source address, the source address mentioned on the packet, and router will update it to the public IP address. I hope you know all of this stuff. It's network address translation. I've created a video on this topic also. You can watch that. Okay. But they are not talking about the router on which NAT is implemented. They are simply talking about a typical IP router. Okay. So typical IP router will never modify source address or source IP address. Okay. They are talking about IP address because it is an IP header. So option B is the answer to the question. I hope you have a good day.